Okay, so this is my last video in this little mini series of characterizing parabola and quadratic functions. One thing that we talked a lot about in class is the number of solutions. Because the quadratic formula contains a square root, we see that some numbers are prohibited, some numbers are not allowed. So if I'm taking a square root of a negative number, I would be asking myself, what's the number that squaring itself gives me that negative number? And no such number exists. No number times itself will be negative. So we have to discard all of those solutions that arise. And these solutions will arise. So we will use something called the discriminant for that. The discriminant is something that we have talked about in class. What are we discriminating here? Well, discriminant, this word is used for discriminating between the number of solutions that we get when we put our quadratic equation equal to 0. So if we get 2 solutions or 1 solution or no solutions, this will be all determined by the discriminant. Okay, so I'm just going to give you the formulas now because this is explained more so in the handouts, and it's explained so where this all comes from. It comes from obviously the quadratic equation for finding the intercepts. So the discriminant is equal to b squared minus 4ac. If you remember from the quadratic formula, the quadratic formula was something, 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 plus minus, and there was this guy here, square root of b squared minus 4ac. There was this little guy that popped up here. So if I'm taking the square root of whatever is here, this guy underneath has to be positive. If it is negative, I get bananas. I get no solution. If it is equal to 0, well, it's allowed, it's perfectly fine. It's just going to be equal to 0, so nothing else will come out of there, okay? 0 is 0. However, if it's larger than 0, then I do get my plus something and my minus something. I get 2 different answers. I should remember that there's also divided by 2a here, right? Some number plus minus, all of this guy here. So let's focus on this discriminant here now. Let's see, in our example, this quadratic equation, how many solutions do I get? So first of all, I need to know what is my A, what is my B, what is my C. So this is that 1 mark question on the quiz again. A in our example is equal to 3. B is, you guessed it, negative 2. And C is a half. Okay. When I have simple fractions like this, I prefer to write 1 over 2, a half, rather than 0.5. Because as you know, mathematics is all about beauty, and this is much more beautiful than writing 0.5. That's an ugly decimal number. 1 over 2 is a beautiful, neat expression. So that's what I'm going to do here as well. And it serves you well if you are in the non-calculator part of the test, because then you are going to have to use fractions. 1 over 2, you know that's equal to 0.5, but what about 13 over 27? Or what about 6 over 108? Like, you don't know what those decimal numbers are, so you're going to keep the fractions. Okay, so let's go back to our little example here. You have b squared minus 4ac. So b squared is negative 2 squared minus 4 times a times c. So a is 3, c is a half. Okay, lots of brackets here now. That's just because we're multiplying everything. Negative 2 squared is 4. Minus, well, 4 times 3 is 12. 12 times a half. So this is 12 divided by 2, right? It's equal to 6. So this is 4 minus 6, which is minus 2. It is less than 0. So in this quadratic formula here, if I would do this using the quadratic formula, if I would try to find the x-intercepts, I would get something that looks like this, square root of negative 2, because this was a negative 2. But this gives me an error. If you put this into a calculator, it will simply not function. You won't get any sensible answer out of it. So if the calculator was a human being that showed emotions, it would be very angry with you. Yeah, it doesn't work. So this means that this parabola has no solutions. So the answer would be no solutions. And I have graphed this using our best friend Desmos. I don't know if you can see in that screen. So this is the actual function that I had in our example, and you see the x-axis is way down here. So the parabola never reaches the x-axis. There is no point where I would have like x-intercepts going through. So if I have no solution, it means that the parabola never touches the x-axis. If a would be less than 0, I would have the same, but underneath. I would have something that goes to negative infinity. I would have a maximum somewhere, but not sufficiently high enough. So it never touches the x-axis. That's the basic message for when I have no solution. So then you might be asked to give me a value for C, for example, for when I do have a solution, either one solution or two solutions. So let's do a quick little example. Please excuse me for turning my back on you. Let's do the same equation, y equal to 3x squared. Same example as we had before, minus 2x, but now I'm just going to add a c. Okay, and I don't know what this c is in our new example, and the question is find c so that we have one solution to y equal to 0. So I want exactly one solution. This means that when I am doing my little quadratic formula here, I'm going x equal to negative b over 2a plus or minus square root b squared minus 4ac divided by 2a. Remember, this formula is given to you, so you don't have to remember it. If I only have one solution, it means that my plus and minus something is going to have to be 0. All of this is going to have to be 0. If this is not 0, it means that I have a number, whatever this is, plus something and minus something. I get two different answers. But I only want one answer, so it's going to have to be 0, so that this plus and minus gives no contribution. That's the only way that I have one solution. So if b squared minus 4ac is equal to 0, let's say all of this inside here is equal to 0, it means that square root of 0 is 0, so everything here disappears. 0 over 2a is just 0, and everything here disappears. So my answer stays in the first part of the formula, plus or minus 0 only, which it's not interesting anymore. It just disappears. So another way to ask this question is, when is b squared minus 4ac equal to 0? Question mark. Well, I know here that my a is equal to 3, my b is equal to negative 2, and my c, well, I'm looking for the c. I don't know what this is. C is a question mark. But let's pop in the numbers that we do know, and let's see if we can solve for c in this equation here. So b is negative 2. I get negative 2 squared. Minus 4 times a. A was 3, so multiply by 3. C, I don't know what it is, so I'm just going to keep it c. I'm not going to change it. Equal to 0. Let's try to simplify a little bit. Negative 2 squared is 4. 4 times 3 is 12, so minus 12 multiplied by c, and that's equal to 0. So now here, I just need to solve for c. So let's add 12c on both sides. It means that 12c on the left-hand side of the equality sign cancel out, but I get a 12c on the other side. So I have the 4 is still there. So 4 equal to 12c. And now I divide by c on both sides. I'm almost running out of paper here, but I think you can see what I'm aiming at. The c's cancel out. Sorry, what am I doing? Divide by c? No, I'm not dividing by c. Forget that. I'm dividing by 12, of course. I'm dividing by 12 because I want the 12s to cancel out. I want c alone on one side of the equality sign and not anything else. So c here, but I have 4 divided by 12. 12 is 4 times 3, so the two 4s upstairs and downstairs would cancel out. I have 1 over 3 left. Please do this carefully. If you are checking the numbers yourself, you should get c is equal to 1 over 3. So the answer, let's write the answer here. The answer is y equal to 3x squared minus 2x plus c. C is equal to a third, so plus a third. So this is my answer for when I only have one solution. Let's see if it works. So let's change this little Desmos guy here now. I'm going to change the last term into 1 over 3. Are you ready for it? Ta-dang! Oh, hey, I don't see. Okay, so it seems to be working because down here is exactly where the parabola is touching the x-axis. So, and it does that at only one specific point, only one place. So that's my solution there, right there. If I would have a c value that's even less, let's take c, let's see, even less, -4. This doesn't seem to work at all. Okay, we're just going to cut the video there. Oh, now it works. Now it works. Let's say I have a c value of even less. I put in -1 over 3. Then you see that the parabola is cutting the x-axis in two values. This is like dragging the parabola down so that the 2 points, I have 2 points that cross the x-axis. If I am increasing my c here, it only touches the x-axis once, exactly on this point. And that was the answer, that's what we was looking for. Okay, I hope these video problem-solving sessions can be helpful for you. Please pause and go back and re-watch them and try to do your own examples. Use Desmos as your friend. You can always check your answers there. And yeah, see you.